Okay guys, so sorry for the confusion here, but basically I just click on pause and then I click the wrong button. Okay, so let's go back to this problem. What we need to know over here is that basically 0 PSIG is basically equivalent to 14.7 PSIA. So basically that means that 6.67 PSIJ will be equal to 14.7 plus 6.69, which will be how much? So it will be 20 plus 1.4, so it should be A over here. Okay, so now let us go to question 6. Alright, so the difference in air pressure over a height of 70 meters if the air density is constant and equal to 1.2 kilograms meter cube will be closest to what? So let me read that again. The difference in air pressure over a height of 70 meters, comma, I guess, if the air density is constant and equal to 1.2 kilograms will be equal to what? So basically that means what is the pressure? So the pressure is pressure will be, if you want, will be rho GH over here, or which is the same thing as gamma H. So this will be equal to what? So this is equal to 1.2 kilograms cubic meters times 9.81 meters second square times 17 meters. Okay, so you take your calculator, that gives approximately 200 pascals, so that would be A over here. Alright, the next one is a sphere of constant density and 4 inches diameter floats in water. They give you density such that the hemisphere is above the water level. What is the weight of the sphere? Okay, so basically here we know that the weight basically is the force done by the fluid, so this will be specific density, so the same as, so rho times the volume displaced. Okay, so this is one equation. So alright, over here let me think 1 second for the units. Okay, so this will be equal to what? 62.27 lb cubic feet. And now we need the volume displaced. So what is the volume of a sphere? Over here, volume of a sphere is 4/3 by r cube. Okay, but here they say, and this is 4 inches. Okay, so it's the hemisphere, so it's half of it. So it should be then 1/2 of 4/3 pi, and r would just be 2 inches. So for diameter will be 2 inches. So 2/12 cube. And if you do the calculation, this will be equal to approximately equal to 0.6. damping force. So it will be option A. Alright, so problem number 8 over here. So this one is the one for two different substances manometer. Okay, so let's see over here. This is a fast way to do it, or you can do all the equations over here, but basically I think the fastest way to do is to select one level point. So basically the pressure at this point should be the same pressure at this point. Okay, so if we go here, this will be our point A, this is B, this is C, D, H, and E. So from this figure we can get that PA should be higher than PC, PB is higher than PC, so that PC is higher than PH. So the answer here will be B. Okay, if you want to have some equation about this, you can say that PB will be equal to PA plus raw oil H1, where H1 would be this height over here. Then, sorry, H1 will be this height over here. Then H2 will be this one over here. Let's say it will be H3, H4, and H5. Okay, so we have this equation. We're gonna have this very quick. So it will be PA, PB. So we start from PA. PB will be PA plus raw oil H1 plus GF H2. PC will be equal to PB minus GF H3. PD will be equal to PC minus density of water H4. Okay, if I keep going, PE will be equal to PD plus gamma of density of water H5. But again, you can do all this stuff just by looking that the pressure at this point needs to be the same one as over here. Okay, so since the fluid is going up, this is higher than PC, then PB, where is PB? Here at the bottom, so it's going to be higher than PC because it's more fluid on top of it. Okay, and then PC over here is higher than PH over here at the highest pressure. So this one will be also higher than the fluid over here. Okay, or you can use these equations. Again, now let's go to problem number 9. What is the minimum force F when applied at central required to open the gate? 50 pounds over 2. 50 pounds over the gate, but it's 2 feet. So what I'm guessing is 2 feet is the width of this gate over here. Okay, so alright, so over here I think we're missing some data, but the classic way to solve this problem is that what would be the area of the plate or the gate in this case? So is the width times the length, but I don't see the length here being given to you. So I think this is the force F. This is 1, 6. So let's see, this will be also the angle over here. So we could have sine of the angle will be equal to what? Will be equal to 5 over the length over here. So basically L is 5 over sine 30, which will be 10. Okay, so then this will be basically the area will be 2 feet times 10 will be 20 square foot. Okay, so what is the force? Force over the area. Alright, so now the force over the area will be equal to what? To the amount of force acting here over that distance. The amount of water acting on top of the plate, okay, will be the value of the force that needs to be done here. So basically what it means is that that force over here will be equal to the average force, really will be equal to this times the area, and then the volume on top times that distance will be y of the CG. Okay, so we know this is given to us 62.4. we know this is 20. We need to find YCG. Okay, so it will be YCG. YCG will be equal to 1 plus that distance over here, which will be what? Plus, so 10 over 2, we take half of 2 and sine 30. So basically this will be equal to 1 plus, this is 1/2, 10 over 4. So this means that this will be equal to 3.5 feet. Okay, so at the end the V average should be equal to 62.4 lb cubic feet times 20 square foot times 3.5 feet. So this will cancel this, the units work out fine, and this should give you about 5,450 lb, which is option D. Okay, so number 10 is select the answer which currently ranks fluid meters from lowest to highest pressure loss. Okay, so we have Venturi tube, flow nozzle, thin plate orifice. Okay, Venturi, thin plate orifice, so I guess this is flow nozzle. Thin plate orifice, Venturi tube, flow nozzle. Okay, this one is tricky, but my guess would be A. I don't know how to explain it in simple words, but select the answer which currently ranks fluid meters. Venturi, okay, flow nozzle, thin plate orifice. Alright, so let's do these extra ones over here. So a pyrostatic tube is placed into air duct and the deflection of the gauge fluid manometer is 1.6 inches of water. what is the velocity of the air in the tub. Okay, so basically that means that if you have a tube over here with flow, and let's say you have here an orifice, you have this, and you have air flowing. This is going to create a difference in pressure. If you have here, if you change, so this difference in pressure is going to be measured by the height in the water. So basically, if you use Bernoulli equation, you're going to find that the velocity difference would be equal to 2 delta P over the density, and this should be V square. Okay, so this will give you 2 times gamma of the fluid delta H divided by the density square, which in this case would be equal to 2 times 62.4 times 1.6, but this is in feet, so divided by 12 to be feet, divided by the density, which is 0.075, but that needs to be divided by 32.2, and this will give you a velocity of 84.5 feet per second. So I will guess option A. You can derive this equation from the Bernoulli equation, or you can just get it from the handouts I gave you. Is in one of them. Okay. Alright, 12. Consider a large field with water. Neglecting friction, what is the steady velocity V2 at the pipe exit if we neglect the change of water height with time? Okay, so alright, so let's say this is 1, and let's say this will be 0.2 over here. So we have that P1 plus 1/2 rho V1 square plus gamma Z1. So this is the Bernoulli equation, will be equal to P2 plus 1/2 rho V2 square plus gamma Z2. So this is our Z equal to 0, so this will be 0. Then no change in pressure, so it looks like over here we're gonna have initially this is just, we're gonna have 1/2 rho V2 square will be equal to gamma Z1. So this will give us that V2 will be equal to the square root of 2 okay, so it will be 2 gamma over density Z1 will be equal to 2G Z1. Alright, so this will be equal to square root of 2, 9.81 times approximately 3. You can do 3 or plus half of this. Let's just do 3, and this will give you a V2 approximately equal to 7.67. So this is D. Okay, so figure 13. In the figure, water is flowing out of the tank through the tube. Okay, siphon. Alright, gravity is acting downward. Set up in this fashion, liquid flows out of the tube because the pressure at point C is higher than the pressure at point A. That should be the answer. So it's C. Okay, makes sense. The pressure here needs to be higher so I can push the liquid around. Okay, I was just planning to do up to here, but I don't know, let's do maybe a couple more. 15. Energy and momentum. Alright, so let's see what would that be over here. So if the pump provides 100 feet of head, what is the discharge velocity at point D? Neglect frictional losses. Okay. So over here basically it's again the same thing. We have P 1 over gamma Bernoulli equation plus V1 square over 2G plus Z1 plus HP, this is the head, minus HL, high, low, equal P2 over gamma plus V2 square, oops, this is dying, gamma plus V2 square over 2G plus Z2. Alright, and we have the value here for the density. So let's say this would be our point 1 and point D, this would be our point 2. So basically there should be no change in pressure because they both have the same height, so this will cancel this one. Then V1 is basically 0, here it's just density. So basically this will give us that V2 square over 2G. Okay, this is low, 0, equal to what? Z1 minus Z2 plus HP. So this is the HP over here, okay? So this will give us that V2 equal to the square root of 2G Z1 minus Z2 plus HP. So this is again the same equation as before, 2G delta H, okay, if you think about it. So this gives you 2 times 32.2 times 60 minus 140, this is 2 plus the 100 of H, and this gives you that V2 velocity approximately equal to 35.9 feet per second. So that would be B. Alright, one more and probably I will stop. What is the pressure at the inlet of the pump if the discharge velocity is 50 feet per second? Okay, so okay, so what is the pressure at the inlet of the pump? So let's say here's a pump. Okay, and flow is going in that direction. So what is the pressure of the inlet of the pump? If we know this velocity here is 50 feet per second. Okay, I'm going to pause for a second the video so I can think about it. Okay guys, so now I just find out that why I had to pause for a second, I had to do this problem is because actually this question here, 15, is related to this problem over here. Alright, so the pump is this one over here. So again, you can just rewrite the Bernoulli equation So now we just look at this section over here, all the figure, okay? So this as before is 0, there is no velocity. This time we don't have any H pump. So over here we solve for P2 will be equal to what? Z1 minus Z2 minus V2 square over 2G. So basically this will be equal to what? 60 for Z1, the distance over here, Z2 is 5, minus the velocity 50 square divided by 2, 32.2. Oh, I forgot here this gamma times gamma, which is 62.27 as given over here. And this, I did the calculation previously, gives you about 6.997 PSIG. Okay, you would get a result here. Really, P2 is equal to 1007.5 lb square feet. Okay, when you transform this, gives you 6.97 PSIG. So you divide by 144. So I will stop over here, and good luck on the exam.